Hello everyone, myself Sagar Ramesh Kute, working as Assistant Professor, Department of Physics, JMD College, Sinnar, Nasik. Now, last lecture we discussed Module 2. Now, in this lecture we discuss Module 3 in topic Optical Feedback, Round Gain Trip and Threshold Gain. Now, first topic is Optical Feedback. This will be the diagram of feedback oscillator and this will be the diagram of optical oscillator. The laser is an optical oscillator. It is a resonant optical amplifier whose output is feedback into its input with matching phase shown in this figure. Now this first figure, feedback oscillator. In the absence of such an input, there is no output, so that the feedback signal is also zero. However, this is unstable situation. The presence of even a small amount of noise at the input unavailable and many initial the oscillator position, that is process. The input is amplified and the output is feedback to the input where the undergoes further amplification. The process continuously identifiably until a large output is produced. Saturation of amplifier gain limit further grow the signal and the system reaches steady state in which output signal is created at the frequency of resonant amplifier. When the oscillator is switched on any noise signal, the approximate frequency appearing in the input will be the amplified. The amplified output given back to the input, a stable output is quickly reached and oscillate act as the source of particular frequency. The laser is optical oscillator in which the amplifier is the pump active medium. The gain saturation is basically property of laser amplifier. Feedback is obtained by the placing the active medium in the optical resonator, which reflects the light back and forth between its mirror. Frequency selection is achieved by the resonant amplifier and by the resonator, which emit only the certain mode. Output coupling is accomplished by the making one of the resonant mirror partially transmitting. Laser amplification, that is gain coefficient. A laser amplifier is narrow band coherent amplifier of light. Amplification is achieved by the stimulated emission from an atomic or molecular system with the transition whose population inverted, that is the upper energy level is more populated than the lower, whose the amplifier bandwidth is determined by the line width of the atomic transition or by an inhomogeneous bonding mechanism such as Doppler effect in gas laser. The laser amplifier is distributed gain device characterized by the gain coefficient, gain per unit length, which govern the rate at which the photon flux density psi increases. When the photon flux density psi is small, the gain coefficient is gamma 0 mu is equal to n0 sigma mu is equal to n0 lambda square upon 8 pi temperature म्हणजे spontaneous lifetime into g into mu, where n0 is equilibrium population density difference. Density of atom in upper energy state means that the lower state n is increases with increasing pumping rate. Sigma mu is equal to lambda square upon 8 pi spontaneous lifetime. G mu is equal to transition cross section. TSP is equal to spontaneous lifetime. G mu is equal to transition line shape. Lambda is wavelength in the medium, that is equal to lambda 0 upon n. N is refractive index. Now this will be the optical feedback. Now next topic, round trip gain. A laser gain is a process where the medium transfer part of energy to the emitted electromagnetic radiation, resulting and increasing in optical power. This is basic principle of all laser. Quantitatively, gain is a measure of the ability of laser medium to the increases optical power. Round trip gain means gain multiplied by the length of propagation of laser emission during a single round trip. In case of gain varying along the length, the round trip gain can be expressed with integral G is equal to integration capital G dz, where G is the laser gain, that is amplification, and small z is the coordinate of in the direction of propagation. This will be the round gain trip. Now next topic is threshold gain. The lasing threshold is the lowest excitation level at which output of laser dominated by the stimulated emission rather than the spontaneous emission. Below the threshold, the output power of laser rises slowly with increasing excitation. Above threshold, the slope of power versus excitation is order of magnitude greater. The line width of the laser emission also become the order of magnitude smaller above the threshold than it is below. Above the threshold, the laser is said to be the lacing. In optical resonator, light undergoes amplification and suffer various losses. These losses occur due to the transmission at the output mirror, scattering and diffraction of light within active medium. For the proper build-up of the oscillation, it is essential that amplification between two consecutive reflection of light from rear and mirror can balance the losses. We can determine the threshold gain by the considering the changes in intensity of beam of light undergoing the round trip within the resonator. Let us assume that the laser medium fills the space between mirror M1 and mirror M2, which has reflectively small r1 and small r2 respectively. Let us mirror may be separated by the distance capital L. Further, let the intensity of light beam I0 at M1. Then the traveling mirror M1 to the mirror M2. The beam intensity increases from I0 to IL, which is given by IL is equal to I0 e raised to gamma minus alpha s into L. After reflection at M, the beam intensity will be the R2 I0 e raised to gamma minus alpha s into L. And after the completed round trip, the final intensity will be the I2L is equal to R1 R2 I0 e raised to gamma minus alpha s into 2L. The amplification obtained during the round trip is capital G is equal to I into 2L upon I0 is equal to R1 R2 I0 e raised to gamma minus alpha s into 2L. The production R1 R2 represent the losses at the mirror, whereas alpha s include all the distributed losses such as scattering, diffraction and absorption occurring in the medium. The losses are balanced by the gain when G is greater than or equal to 1 or I2L is equal to I0. It leads to condition that R1 R2 I0 e raised to gamma minus alpha s into 2L is greater than or equal to 1. E raised to gamma minus alpha s 2L greater than or equal to 1 upon R1 into R2, taking logarithmic on the both side. 2L gamma minus alpha is greater than or equal to log R1 into R2. Gamma minus alpha s greater than or equal to 1 upon 2L log R1 into R2. Gamma greater than or equal to alpha s minus ln 1 upon 2L R1 into R2. Gamma greater than or equal to alpha s plus 1 upon twice L ln 1 upon R1 into R2. This above equation is known as condition for lacing. It implies that the initial gain must be exceed the sum of losses in cavity and amplification of laser mu, that is gamma, will be dependent on how hard the laser medium is pumped. This condition is used to determine the threshold value of pumping energy necessary for the lacing action. Now this will be the derivation of threshold gain. Now in this lecture we will discuss optical feedback, resonator, round gain trip and threshold gain. Thank you so much.